heat loss from a steam pipe in windy air. So this is the question, a long 10 centimeter diameter steam pipe whose external surface temperature is 110 degrees Celsius passes through some open area that is not protected against the wind. So the surface temperature of this steam pipe is 110 degrees Celsius. And then determine the rate of heat loss from the pipe per unit width. So we have to find what is the heat loss from the pipe per unit width of its length. So from here, we know that we have to find what is the Q dot over L. Okay. When the air is at 1 atm pressure and 10 degrees Celsius, so we have the pressure is 1 atm for the wind and 10 degrees Celsius is T infinity for fluid. At this point, our fluid is wind, air. Okay, and the wind is blowing across the pipe at velocity of 8 meter per second. So we have the velocity of the wind at 8 meter per second. So we may found the properties of the air by calculating the fluid temperature, film temperature, where we have to sum up T surface with T infinity and divide by 2. So we have 60 degrees Celsius and refer to the tables table A15 at 1 atm and 60 degrees Celsius. You will take out the value for the K, thermal conductivity, Prandtl number, and kinematic viscosity. All these properties will be used for determining required values for Nusselt number and Reynolds number. Okay. Sometimes it is not been given in your final exam, but sometimes normally all these properties will be given in your question. Okay, so first you have to for you to determine what is the rate of heat transfer over length or per unit length. From rate of heat transfer, we know that the equation is H times with surface area and times with delta T. So at this point, delta T is, so here T infinity is 10 degrees Celsius and your T surface is 110 degrees Celsius. Therefore, the heat transfer will be from 110 to 10 degrees Celsius. So heat transfer from surface to fluid. So your Q dot is H AS Ts minus T infinity. Okay, that is the equation. But right now, in the question, H value is not being given. So this H value, you cannot find it in the table. But how you can find this H value? You may find this H value by calculating it. So we know that there are two equations for the average Nusselt number. So average Nusselt number for cylinder, we can use the Childs and Bernstein equation. And then for the sphere, we will use Whittaker equation. So in this question, we know that the shape of the steam pipe is circular. Therefore, we directly use Nusselt number for the cylinder. From Nusselt number cylinder, we can equate this value with HD over K. From this value, from this equation, we can rearrange to get what is H. Okay, so let's do this example. So first, what you need to do is you have to find what is Reynolds number. So Reynolds number D, since we are dealing with circular, so I change this from L to D, so equal to rho V D outer divided by kinematic viscosity, or Reynolds number D equal to V D outer divided by kinematic viscosity. So substitute the values based on the information given or information that extract from the tables. We can use this equation, but actually in the tables we can find the value for the viscosity and density, but right now I will use the Reynolds number for kinematic Reynolds number where we have to use kinematic viscosity in the question, in the equation. So Reynolds number is equal to, so velocity of the wind is 8 meter per second. So times with 0.1 meter is the diameter for cylinder, and divided by kinematic viscosity is 1.896 times 10 to the power of minus 5 meter square per second. So you must remember that all these units must be in SI unit. So if your diameter is centimeter, therefore you have to change to meter. So we will get the Reynolds number is equivalent to 4.219 times 10 to the power of 4. So for a flat plate, we know that if we already determine the Reynolds number, we have to compare with Reynolds number critical in order to determine whether that flow is turbulent or laminar. But at this point, for the circular and sphere, we will not compare with the Reynolds number critical, since we only have two different types of equation, one for cylinder and one for sphere. Therefore, you will directly use that equation. So now we know that this question is for cylinder, therefore we substitute all the values inside the Nusselt number for cylinder. So you have to, number 2, substitute. So substitute into Nusselt number for cylinder. So when you substitute, you will get the value of Nusselt number cylinder is equivalent to 124. So here, so this equation. So because we deal with steam pipe, where steam pipe is cylinder in shape, therefore we use Nusselt number cylinder. So substitute into Nusselt number cylinder, you will get 124. So number 3, after you get the Nusselt number, you have to find what is the heat transfer coefficient. So heat transfer coefficient. So how you want to find the heat transfer coefficient? So we know that Nusselt number cylinder is 124. And we have to equate this value with equal to HD out divided by K. Rearrange this equation to find what is H. H is equal to 124 times with K divided by D out. So substitute all the value times with 0.02808 watt per meter dot Kelvin divided by outer diameter is 0.1 meter. Therefore, you will get H value is equal to 34.8 watt per meter square dot K. So this is your heat transfer coefficient. In your question, it needs you to find what is the rate of heat transfer per unit length. Therefore, you have to substitute into the equation number 4. So Q dot equal to HAS Ts minus T infinity. As I mentioned before, Ts is much more greater than T infinity. Therefore, the heat transfer from Ts to T infinity. So rearrange the equation Ts minus T infinity. So now we already determine what is the value for H and As. So As is pi dl. Now we do not have any value for L. The question does not state the length of the steam pipe. Therefore, you have two ways. First, you may assume. So assume that length of your steam pipe is 1 meter, or another method, you let it L terms in your AS equation. So I will use the second method where I do not want to change or to substitute or to assume any length values. So therefore, I will remain AS as pi dl. Remain AS length as L. So to calculate AS is pi times with D is 0.1 times with L. So I will get this value equal to 0.314 L. Okay. Then I substitute into this equation. So to find what is Q equal to H. H value is 34.8 times with this value 0.314 L, okay, times with 110 minus 10. So this is T surface minus T infinity. So here I have L terms. I will bring these L terms into left hand side. So this left hand side will be Q dot over L. Therefore, I will get this 1093 watt per meter. So I already answered this question. If you assume L is 1 meter, therefore you have to note or give some words here, sentence here, that this value is for 1 meter. Okay, that's all. Thank you.